Okay, so this is video just to show the locomotion movement of our robot that we made for ECD agricultural smart agricultural robot competition. Obviously we couldn't get it moving at the time because we were using the OpenMV and we were having issues with that. So I'm just going to show the movement, how the AI works. For the locomotion part of the robot, as you see, I've replicated the part of the track that we used. The black squares, obviously that's where the robot is at the moment. It's the start square. They're all exactly the same size, 600 by 600 blocks. Inside those black squares is obviously going to be the white, represents the white parts of the track, and all the rest of it represents the black. And I don't have a lot of room, so I've only sort of replicated maybe a quarter of it, and I've placed two wire rolls representing blue objects. Obviously for the purpose we're using, we don't need to use the blue blocks. We've put two in place, so I think this one is our coordinates 3000 and 2700, and the other one over here is coordinates 2100 by 3900. So in this we're just going to move from the start position where the robot is. Obviously it doesn't have the arm or anything to pick up the block replicas. It's going to move firstly to the position where this coil of wire is, so that was represent one blue block, and the second blue block over here with this other coil of wire. So obviously the robot's going to move to the first one, then it'll stop. I'll take that away because we don't actually have the arm to actually pick it up, and then it's going to move to the position of the second block, just to show the locomotion and the AI is working. Okay, so we're at the terminal. I don't have the wireless system to be able to do this wirelessly, so I've had to connect to hardwire to the Arduino, so it's going to have to move around with it as it moves. We've used a grid system, the ones where we can't move and the zeros where we can. They're representing 75mm blocks. Okay, so when we start the program, it asks for coordinates. It's going to ask for coordinates of 3 sets of blocks. First coordinate for the first Y is 3000. That's the X coordinate. Then the Y coordinate will be 2700. 2100 for the second quarter wire, and 3900 for the Y coordinate. Now it'll ask us for the third lot, which is really irrelevant because we're not getting to that. So I'll just put an arbitrary in there, and it pops out the grid. Okay, so it gives us the block numbers, so it's mapped it from the grids to the block numbers. The first one's 4036, the second block is 2852, and the third block is really irrelevant. And as you can see there, so the third block is 44. So it is pop the 2, we change the number to a 2, row 4, column 4. Remember it's working on a 0 to the first column is zeros. And I've just scrolled down and you can see where the second lot, the first and second block here, that would be the second block, and down there is the first block. So let's put a 2 in there just so we know where the blocks are. So now it's asking for the command to start locomotion, which is a capital L, so I'll pop that in there, into that, and then it asks for the bearing. This will be, like, obviously this is replicated from what the OpenMV would be sending. We'd be asking the OpenMV, and it would give us a block position. So the first one will be I think about 165 from the start point. So from the start point here up to the first block there, the first coil of wire is about bearing about 165. Pop that in, 165. Okay, so now hit enter on that 165 and we should move up to close to the first block and move in a straight line. Now it'll stop there. And I'll enter in the next bearing. So if we're looking at that, we're looking around about 150, 145 degrees from the center of the robot, which is what the MV would tell us. So pop that in, 145 bearing, hit enter, and it should move across to in line with it. Okay, so now that we're at that point, the MV would return bearing of 180, roughly 180, could be either way. I might make it 179 or something like that, just to show it's not exactly, doesn't exactly have to be 180. And then if I hit enter, it should go to the block and stop just before the block. Right. Then we come up, so it'll stop at the block and we'd be able to do the retrieval, which obviously I don't have the gear to do at the moment. But what has happened here, you can read that it's come up, so with block 1 is in vicinity, conduct arm retrieval. That's what's happened. So we've got to within the block. The block counter is now 1. Now it would have done the retrieval. Block counter was now 1, and it would recalculate the grid. So where the grid was, where that block was in the first place, which would have been somewhere around here, has now been taken out. So the 2's been taken out. And we're left with just the 2 up here, which is the last block. So I've taken that block out of the way. We just got the second block up there to get to, just to show that it can repeat. Obviously it's come up here. We're now moving to retrieve block 2. This is just some stuff that I've put in just as we go along. So I need to enter a bearing to the second block. So if we look at that bearing is roughly, I would say, about 150-ish. 90 being straight out that way. It'd be a bit over 130, a bit over 45 from 90, so say about 150. Okay, so I've entered 150 in. I should just move to the centre of those 4 blocks, bring us to a crossroad in the car. Hit enter. Move us to the centre. I've just moved that because the cord's a bit short, so up to the centre. Now we're in a bearing about 120, so I'll click that in. 20, hit enter. So we had a bit of wheel slippage there, so just have to move it forward a little bit. This thing we're on here is quite slippery. Yeah, I just moved it forward a touch, just to compensate for that slippage. It should have moved up to about roughly where it is there. There's a bit of a dip in the floorboards here. So anyway, so the last one is, we're on a bearing now of about 180. So I'll plug 180, and this should stop just before the wire. Hit enter. That's it. As you can see, it stopped just before the wire. We probably needed to stop it a little bit further behind, but that would have been sorted out with testing when we had the bucket on front, so it's all working pretty well. Yeah, but that's sufficient. Alright, so just showing the console here, it says block 2 is in vicinity, The block counter is now incremented to 2. New grid has been made up. So the block would have been somewhere around here. Should have been a 2. Now it's been put back to a 0, so it's been taken out of the equation because it would have been retrieved. And then next thing would have called for bearing to the third block. So in conclusion, you can see that the locomotion system worked quite well. The AI worked well. All we needed was for the OpenMV to send us bearings and coordinates, and I think we would have hit the mark each time we wanted to. Thanks for watching.